Hello friends, welcome to CSS Study Bytes. In the previous lecture, we saw what is scheduling, and today we will learn first scheduling algorithm that we call as first come first serve or FCFS. Okay, we learn it by doing one of the numericals. So here we have process numbers is given. It will be given there in the question, and arrival time will also be given there. Arrival time, and then we have burst time, or we call it as execution time. Okay, and here we have criteria. What is the criteria? Here criteria is arrival time. What does it mean? Arrival time. It means that those processes that will be available, the process that will first come and he will be served first. It will be executed. So processes will be executed in first come first serve basis. So here we have criteria is arrival time, and we will check arrival time of each process, and if it is available we will execute it. Okay, then we have mode non-preemptive. What does it mean, mode non-preemptive? It means that the process that is available here, that will be executed fully. Okay, so now we will start. Here we have one Gantt chart. What is Gantt chart? In the Gantt chart we will start from 0. Here we are taking from time 0. From time 0, we will check first which process is available at time 0. Okay, at time 0, which process is available? Check the arrival time of each process. Here we have arrival time 0. That means our process number 1 has arrived at time 0. So that means at time 0, our process 1 is available. We can execute it. So take process number 1. So we can take here as process number 1, and it will be executed for how much time? For 2 units of time. That is from 0 to 2, our process P1 will be executed. Okay, now at process at time 2, which process is available? At time 2, which process is available? So here we have at time 2, arrival time 2, we have process 2 is also available and process 3 is available. Now which process should be executed? Here we will check first which process has arrived first. So process number 2 arrived at time 1. Okay, so we will execute, and process 3 has arrived at time 2. But here our criteria is arrival time. Those processes will be executed first, the process that arrived first. So here process 2 has arrived at time 1, so we can execute process 2 first. So here we will execute process 2. Okay, and what is this burst time? That means it will be executed for 5 time units. Okay, from 2 to 2 plus 5 means at 7 it will complete its execution. Okay, so now we are at time 7. Which one is available? All the processes have arrived at time 7. So now which one will be executed next? So we will check arrival time. So P1, that's completed, P2 completed. Now P3 has arrived at time 2. P4 has arrived at time 3, and P5 has arrived at time 4. That means the process that has arrived first, that will be executed first. So P2, process number P3 arrived at time 2. So we will execute process P3. So P3 will be executed, and P3 will be executed for 3 time units, that is 7 to 10. Okay, now P3 is completed. Now P4 is available. We can execute P4. And what is its burst time? Its burst time is 1. 10 plus 1, 11. And after that P5 will be executed. And it will be executed for 6 time units. That is 11 plus 6, that is 17. So it will complete its execution at 17. Okay, now we have to check completion time. So we will check when our different processes completed their execution. So P5, what is the completion time of P5? P5 completes execution time at 17. We can go to here, P5 17. Okay, P4 its completion time is 11, P4 11, P3 its completion time is 10, P2 completion time is 7, P1 its completion time is 2. Okay, done. Completion time done. Now we have to calculate turn around time. TAT means turn around time. Now we know what how to calculate turn around time. Turn around time equal to completion time minus arrival time. So what is the completion time of each process minus what is the arrival time of each process. Now we will check completion turn around time of process P1. What is it? It is completion time minus arrival time. Completion time of process P1 is 2. 2 minus arrival time that is 0. 2 minus 0 that is 2. Okay. And similarly, process completion turnaround time of process P2 is 7 minus 1. Completion time minus arrival time 7 minus 1 that's 6. P3 10 minus 2 that's 8. P4 11 minus 3 that's 7. And P5 17 minus 4 that is 13. Okay, so here is the total turnaround time. What how much it is? It is 37. 13 11 minus 3, sorry, it's 11 minus 3. 11 minus 3 that's 8, not 7, sorry. 13 plus 8, 21 plus 8, 29 plus 6, 35 plus 2 that's 37. Okay, now we have to calculate waiting time. Now we know waiting time is equal to its turn around time minus burst time. How much a process has to wait. So what is waiting time? How much a process has to wait for its turn. Okay, so turn around time is 2. 2 minus burst time. We will calculate waiting time of process P1. It's 2 minus 2. Turn around time minus burst time. 2 minus 2 that's equal to 0. Okay, why it's 0? Because whenever at time 0 process P1 was there, so we executed at time 0. So it process P1 doesn't need to wait. Okay, it was arrived and it was executed. Okay, so now check waiting time of P1, that is 6 minus 5 that is equal to 1. Okay, now we will see waiting time of process P3. So how to calculate its turnaround time minus burst time, that is 8 minus 3 that is equal to 5. Okay, then waiting time of P4, it's 8 minus 1 that is 7. Then waiting time of P5, that is 13 minus 6 that is equal to 7. Okay, now we will check total. It's 13 plus 8 that is equal to 21. 21 plus 8 that's 29. 29 plus 6 that's 35 plus 2 that's 37, and this is 14. 14 plus 6 that is equal to 20. Now we will check what is the average turn around time. Average turn around time, that is total turn around time, that is equal to 37 divided by total number of processes. How many processes we have? We have 5 processes. 37 divided by 5 that is equal to 7.4. And average waiting time, how to calculate? Average waiting time, that is equal to total waiting time, that's 20 divided by number of processes, that is 5, that is equal to 4. So now we got average turnaround time as 7.4 and average waiting time as 4. Okay, now here I have written one point, that is if the arrival time of two processes are same, then schedule the process which has largest process ID. What does it mean? Here we will take one example. Like we have process P1 and P2. Suppose both arrived at time 0. Both arrived at time 0. Now I have to execute. At a time I can execute only one process. Now which process I need to execute? So here, because both are having same arrival time, both are arrived at same time. Now I have to execute one process. So but I don't know which one to execute, because both arrived at first same time. So here is my solution. If the arrival time of two processes are same, then schedule the process which has lowest process ID. Which one has lowest process ID here? It is P1. So I can execute first P1, then I can execute P2. Okay. Okay. So now I will show you what is convoy effect. What is convoy effect? There is one problem in the first come first serve that we called as convoy effect. So here I will take first example. I will make you understand by taking this example. Okay. So here we have P1, P2, P3, and we have arrival time, and we have given burst time. Okay. So let's here let's take the Gantt chart. Gantt chart. Okay. Gantt chart. So it will start from 0. So which process has arrived at time 0? It is process P1. Okay, P1 has arrived at time 0, so it will be executed first. What is its burst time? It's 20. So it will be executed for 20 units. Okay, after that, so at time 20, which process is available? I have all other processes are available. That is P2 and P3. P2 arrived at P1 at time T1, that is so P2 will be executed first. So P2 when it will complete its execution, it will execute for 2 units, that is 20 plus 2, that is 22. Then P3 will be executed. P3 will be executed for 2 time units, that is it will complete its execution at 24. Okay. So now we have completion time. Completion time of P3 is 24, P2 is 22, and P1 is 20. Okay. Now turnaround time. How to calculate is completion time minus arrival time, that's 20. 22 minus 1, that's 21. 24 minus 2, that's 22. So what is okay? It's it's 63. Because 22 plus 21, that is 43, plus 20, that is 63 total. Okay. Now we will check waiting time. Waiting time is, we know waiting time equal to turnaround time minus burst time. That's 20 minus 20, that is equal to 0. 21 minus 2, that's 19. 22 minus 2, that is 20. How much is the total? Is 39. Now we will check average turnaround time, that is equal to 63 divided by 3, that is equal to 21. And average waiting time, we have total waiting time is 39. 39 divided by 3, 39 divided by 3 by 3, because total process we have 3, that is equal to 13. Okay, so we got average turnaround time and average waiting time. Now we will execute same process. I have all here we have 3 more processes. But what we will here do, we have taken burst time, large burst time of first process. Here we will take the large burst time of third process. Only a single change here. Now we will check how it will affect its average turnaround time and its average waiting time. Okay. Here take Gantt chart of this thing. So it will start from 0. Which process is arrived at 0? That's P1. And what's its burst time? It's 2. So P1 will be executed for 2 units. Then which process is available at time T2? Both P1 and P2 both are available. So P2 will be P2 and P3. P2 will be executed next because it arrived first. So what is its burst time? It's 2. So it will be executed for 2 units. And then P3 will be executed. What's its burst time? It's 20, and 20 plus 4, that's 24. Okay, what's the completion time of P3? It's 24. Completion time of P2 is 4, and completion time of T is 2. What's turnaround time? That's completion time minus arrival time, that's 2. 4 minus 1, that's 3. And 24 minus 2, that's 22. What's waiting time? That's turnaround time minus burst time, that is 0. Turnaround time minus burst time, that's 3 minus 2, that is 1. 22 minus 20, that's equal to 2. What is total? It's 3. And what's its total? 22 plus 3, 25 and 27. Okay. 27. What now we will calculate its average turnaround time. What's the average turnaround time? That's 27 divided by how many processes? 3 processes. That is equal to 9. And average waiting time that is equal to total, that's 3 divided by number of processes, that is equal to 3, and average waiting time is 1. Now compare this with this. Here we have average turnaround time 9, and here is average turnaround time is 21. Average waiting time is 1, and here average waiting time is 13. So there is a huge difference. So why there is this huge difference? This huge difference we called it as the Convey effect. What is Convey effect? In the first come first serve, if the first process is having large burst time, then it will have the major effect on the average waiting time of all the processes. If here in this example we have large waiting time for burst time for the first process, so it has effect on average waiting time and average turnaround time of all the processes. But here we have the first here the large burst time is only the process P3 is having large burst time, so it has these processes do not need to wait too much. Okay, so this is called the Convey effect, and we have also seen this. If you are traveling to some place and there is one convoy is going on, so you have to wait till the convoy gets over. Okay, so this is how the Convey effect is. Okay, hope you understand each and everything about this lecture. If you really like this lecture, then you can please like, share and subscribe. See you in next lecture. Allah.